Let's talk about enthalpy of dissolution. This is the heat change that occurs when a substance dissolves in water to form a solution. The heat change can be as a result of heat absorption, hence this process is endothermic. Or heat evolution, and then we'll obtain exothermic. So when there is heat absorbed, then we had said that is endothermic process, but when there is exothermic, then heat is released. So dissolution can be either giving us absorption of heat or release of heat. For example, both sodium hydroxide and conc sulfuric 6 acid dissolve exothermically. Meaning they dissolve by release of heat. While if we have a solution or a solid substance of ammonium nitrate to dissolve, that one dissolve endothermically, meaning heat is absorbed. In determining heat of solution of a solid, we still have the formula delta H is equals to mc delta T, where m is for mass of water and can also be assumed as mass of the solid. From an experiment done using 2 grams of ammonium nitrate, solution of that, we can have 2 grams of sodium hydroxide. We can go ahead and determine the molar heat of solution of these two substances. Let us start by case 1, that is for ammonium nitrate. Given that delta T is 1 Kelvin, let's go ahead and calculate the molar heat of dissolution for this ammonium nitrate. Well, recall that delta H is mc delta T, where m is the mass. So the mass of water used is 100 cubic centimeters. So that means 100 cubic centimeters as the volume, and that implies that the mass is 100 grams. Remembering that the density of water is 1 gram per cubic centimeters. Now, delta H is equals to 0.1 kilogram times 4.2 kilojoule all over Kelvin per kilogram times 1, meaning 1 is the change in temperature. So that cancels, and that also cancel out. So we have 0.1 times 4.2 giving 0.42 kilojoule. That can also be 420 joules. J has to be capital because that is the name of a person. Let's go ahead and calculate number of moles of ammonium nitrate. That is mass of 2, molar mass is 80, giving 0.025 moles. Now, this implies that if 1 mole, if the moles that we've calculated, that is 0.025 moles, is able to generate 0.42 kilojoule watt of 1 mole. So that is 0.42 kilojoule by 1 all over 0.025 mole. So that gives, divide by 0.025, and that is 16.8 kilojoule per mole. Since the process is endothermic, the sign is positive, meaning energy is absorbed. Let us do the same to come up with what we call a thermochemical equation. Then we represent the same in the energy level diagram. Thermochemical equation, that is sodium nitrate solid is dissolved in water to form aqueous sodium nitrate. That is a solution. Delta H is positive 16.8 kilojoule per mole. Let's have this in the energy level diagram. The illustration in the energy level diagram, we have reactants, then products, that is activation energy. So that gives a delta H value of plus 16.8 kilojoule per mole. Reaction progress, energy, in kilojoule. Then we have the two normal axes. So that is solid ammonium nitrate reacting with water or dissolving in water to form aqueous ammonium nitrate. That is the energy level diagram for the dissolution of ammonium nitrate. Let's calculate now for sodium hydroxide. Here we are given a delta T of 5 Kelvin. Mass of water, that is volume of water, as 100 cubic centimeters. Let us go ahead and calculate molar heat of dissolution. Then delta H is equals to MC delta T the M is 0.1 kilogram multiplied by 4.2 kilojoule per Kelvin per kilogram times 5 Kelvin. That gives that, and that cancels that. So we have 2.1 kilojoule. This process is an exothermic process, therefore it gives a negative value. Now, after obtaining the delta H, that is the enthalpy change, let us go ahead and determine molar enthalpy change. by simply starting with the calculation of moles of sodium hydroxide, that is 2 out of 40, giving 0.05 mole. If 0.05 mole gives 2.1 kilojoule, what of 1 mole? That is 2.1 times 1 over 0.05, giving a new value, and that is negative 42 kilojoule per mole, as the molar heat of dissolution of sodium hydroxide. Thermochemical equation. Let's write the thermochemical equation, that is sodium hydroxide solid dissolving in water to give aqueous sodium hydroxide. Delta H is equals to negative 42 kilojoule per mole. Let's have the illustration in the energy level diagram. Remember, the reaction is exothermic. So we have the reactants. Then after that, we'll have the products. So that is sodium hydroxide in solution. Then we have the pellets. Activation energy. Delta H is equals to negative 42 kilojoule per mole. This is reaction progress or path. Then we have energy in kilojoule. So that is the dissolution of sodium hydroxide. When dissolving a liquid, the resulting solution has a volume which is the sum of the volumes of the liquid and the solvent. For example, when dissolving sulfuric 6 acid, let us take volume of sulfuric 6 acid to be 2 cubic centimeters. and that of water as 98 cubic centimeters, meaning total volume of solution will be 2 plus 98, giving 100 cubic centimeters. Let us use this information of delta T also as 7 Kelvin, density of sulfuric 6 acid as 1.84 grams per cubic centimeters, percentage purity 98%. Well, using this information, we want to calculate molar heat of dissolution of sulfuric 6 acid. Delta H, as usual, if we start by calculating delta H, we have a mass of 0.1 kilograms, times 4.2 kilojoule. The difference in temperature is 7 divided by Kelvin per kilogram. So this implies that we have 0.1 times 4.2 times 7, that is 2.94 kilojoule. Let's calculate moles of the acid. We first have to calculate the mass of the acid will be calculated as follows: 1 cubic centimeters as 1.84 grams. So 2 cubic centimeters, that is to be dissolved, has 2 times 1.84, giving 3.68 grams. Of this, only 98% is pure. So 98 times 3.68 grams, that will give 98 by 3.68 divided by 100. We obtain 3.6064 grams. Now, this implies that moles of the acid will be the mass, which is 3.6064, over the molar mass, that is 98. That gives, divided by 98, giving 0.0368 moles. After that, we now know that if zero point 0.0368 moles is able to generate 2.94 kilojoule. What of 1 mole? So that will give 1 times 2.94 kilojoule over 0.0368 mole. So we have 2.94 divided by 0.0368. That gives 79.891 kilojoule per mole. That is the enthalpy of dissolution of sulfuric 6 acid. So because it is an exothermic reaction, the value is negative. And that is all about enthalpy of dissolution.